Hello my dear students, in this video we're going to learn some applications of Euler circuit and Euler path. In transportation, let's say we have this problem. A subway map is shown below as the map. Okay, so in this map, we consider these points here as the vertices in a graph. And these lines are actually the edges. So this can also be the graph, okay? Now, to determine whether there is an Euler path or an Euler circuit in this graph, we just need to determine the number of odd degree vertices. If there's no odd degree vertices, there is an Euler circuit. And if there is exactly 2 odd vertices and all others are even vertices, we can conclude that the graph actually has an Euler path, and that will actually answer our problem. Okay, so we're going to count now or determine now the degree of its vertex. So what's the degree of this? The degree is 2 because there are 2 lines connected to it. The degree of this vertex is actually 4. How about this? It's 3. How about this? 2. This vertex here, the degree is 4. This one, the degree is 2. And here we have a degree of 4. This one has a degree of 2. This one has a degree of 2. Here, 2. This one, it's 3. This one, 4. This vertex has a degree of 2. This one also has a degree of 2. And this one has a degree of 2. Okay, so looking at the degrees of all vertices, there are actually 2 vertices with an odd degree. That is this vertex and this one. Okay, so there are exactly 2 odd vertices. So we can conclude that in this graph or this subway map actually has an Euler path. So if there is an Euler path, is it actually possible for the rider to travel the length of every subway route without repeating any segments? Yes, because that's actually the definition of an Euler path. If he starts with this vertex, okay, he can actually pass through all the other edges or lines exactly once, and he ends at the other vertex with an odd degree, this one. So to answer this problem, yes, it is possible. Okay, another application of Euler path and Euler circuit, this time in the field of architecture. So a floor plan of a museum is shown. So this is actually a floor plan of a museum. Draw a graph that represents the floor plan where its vertex represents a room. So a vertex represents a room and an edge connects 2 vertices if there is a doorway. So the doorway will become an edge in the graph. Question: is it possible to walk through the museum and pass through its doorway without going through any doorway twice? Or the next question is, does it depend on whether you return to the room you started at? Justify your answer. So it's also a problem of Euler path and Euler circuit. The first question is regarding Euler path, and the other one is asking whether there is an Euler circuit because you need to start or you go back to the starting point. So the first thing to do is how to convert this floor plan into a graph. So it says here that a room becomes the vertex. So how many rooms are there in this design or in this floor plan? We have 1, 2, 3, 4, 5. Okay, and these rooms are actually the vertices. So I will put points here, and the doorway will become the edge. So for every doorway, there will be lines connecting the vertices. So we have here a line that connects these 2 points, and there's another line that connects both points but with a different doorway. And then it's so we also have it here, okay, and it is also connected to the other point here. And this point, there is a doorway going to this room, and in this room there's a doorway going to that point, and in here there's a doorway going to the other point, and this point here we should be connected to this point because there is a doorway. So we have actually 5 vertices corresponds to the 5 rooms, and we have how many doorways? 1, 2, 3, 4, 5, 6, 7, 8, and that corresponds also to the 8 edges. To answer the problem, we just need to find whether there's an Euler path or an Euler circuit, and that is to count the number of odd vertices. So if there are none odd vertices or there is no odd vertices, that will be an Euler circuit. Then you can answer the second question here, that you can go back to the starting point. For an Euler path, there should be exactly 2 odd vertices. So now let's find, or let's determine the degree of its vertex. So what's the degree of this? 1, 2, 3, 4. How about this? 1, 2, 3, 4. How about this? It's 4. And this one, 2. And this one, 2. So what can you say about the degree of its vertex? They are all even because the degree are either or is either 2 or 4. Therefore, all the vertices are of even degree. Therefore, we can conclude that there is an Euler circuit in here. So to answer the problem, is it possible to walk through the museum and pass through its doorway without going through any doorway twice? Yes, it is possible. And does it depend on whether you return to the room you started at? Yeah, you go back. You may go back to the starting point. Okay? Because it's an Euler circuit. And here is another floor plan, the same with the architecture. So I leave this as your assignment. You need to try this out. Okay? And these are some of the applications of Euler circuit and Euler path. Thank you. See you again in the next video. Bye.